This video will look at correct export and understanding of the IFC file or Industry Foundation class inside of Autodesk Revit. The learning content will be understanding IFC versions, setting appropriate IFC types, your IFC export settings, and how to export IFC files. Inside of Revit, using the Industry Foundation class file or IFC file is crucial to drive open collaboration and open BIM. The IFC file by Building Smart International is used as an open, collaborative file format that isn't tied to any individual vendor. The IFC file will export 3D geometry, such as this door, as well as information attached to that door, whether it's instance properties, very specific BIM data like Kobe, type properties, or other BIM data like IFC specific property sets or classification systems. The IFC file won't support 2D, so annotations won't be exported. Specific 2D detail, such as hatches or line work, won't be supported. And these will things like section or detail views. The IFC file will support a decent 3D export with a decent level of information. But there's a lot of rules and regulations and a lot of do's and don'ts to make sure that you're ready to export the IFC correctly. Let's go through some of them now. First things first, you need to identify which version of IFC the project is using, and typically that will be noted within your BIM documentation, such as the Building Information Modeling BIM Execution Plan. Check other contractual documentation if you're unsure. Inside of Revit, we have some defaults. If you go to File, Export, and scroll all the way to the bottom of the screen here to Options and IFC Options, we can see a number of different categorization. Those categories inside of Revit link directly to types inside of the IFC. This is a mapping exercise, and the default one does a pretty good job, but there are some things that you need to look at and need to understand. For example, an air terminal in Revit will export as an IFC air terminal, no problems at all. A door in Revit will export as an IFC door, again as expected. If we come down to some of the M&E components, have a look at duct insulation and duct lining. Within an IFC, they are known as an IFC covering. The same for both. However, you will notice that although they have the same IFC class name inside of Revit, they have a very different type name. These have subcategories known in the IFC as enumerations to better define what that component is. Because we're working between multiple different technologies and applications using the IFC, it's important that we have something that fits all. So generally speaking, we have less main categories that are then subcategorized within them. This makes the control of information and geometry easier between applications. Some more examples of this, if we scroll in a little bit further, are things like ducts. A flexible duct is an IFC duct segment, but its subcategory, or IFC type in this dialog box, is flexible segment. If we have a look at a standard duct, we can see that it's also an IFC duct segment, but it's not subcategorized because it's just a duct. This can be very confusing to begin with, but it's important that you understand what this means in reality and how, dependent on what version of IFC that you're using, this can be very different with regards to the outputs. One final example from me in this dialog box is something like mechanical equipment in Revit. Inside of Revit, mechanical equipment is a catch-all. It can be used for many different pieces of mechanical equipment, such as a boiler, such as a VAV unit, or an air handling unit. Therefore, when it exports to the IFC, it exports as a catch-all, an IFC building element proxy. This is a non-specific geometry output that will not give a good level of information against it and will not give a good specific amount of detail in the export. It's important that you understand how to handle these correctly inside of Revit. Now, first things first, how do we know what IFC classes we have and what IFC types we have next to them? As I said, first things first, check your documentation and understand what version of IFC you're working with, because the two are very different. If we go onto the web and do a search for IFC 2x3, we can find the documentation for that release. Let's have a look in the alphabetical listings, look at the different entities, and maybe for the purpose of this, scroll down to something architectural, like an IFC door. If we look at this IFC door and click it, we can see that the door has a whole vast amount of information. That information spans from what it might look like, the different types of opening style, and how that should be used. Against that, you also have some property sets. Against the geometry in an IFC file, you'll also get P sets or property sets for those different types of component. A door will have three property sets: pset door common, pset door window glazing type, and pset door window shading type. To be a valid IFC, you must have these property sets within your IFC, and these property sets must have these values. If you leave a default export in any application, you won't meet the full requirements of this IFC standard. Let's go and have a look at another type. Let's scroll down and have a look at IFC duct segment type, another one that we looked at inside of Revit. Let's open it up, scroll down, and see that we have the property sets here, preset duct segment type common, which shows us all of the properties that we should have against that duct. As well as that, we also have, for certain types of component, enumerations. These enumerations will give us different subcategories. Here is our rigid and flexible duct types that we saw in Revit. The IFC duct segment type we put into the IFC class section inside of Revit. If we need to subcategorize it, we use these enums, enumerations, in order to tell Revit what specific type of component you are using. And there are several examples of this throughout the IFC page. For the mechanical equipment example, we'd be more specific in IFC. If it was a boiler, we would choose IFC boiler type. But we don't have a boiler category inside of Revit. So it's important that we understand how to tell a component in Revit what type it's going to be and what subtype it's going to be. Let's see how we do that now. Before we do so, don't assume that the two versions of IFC are the same. The list of IFC entities in 2x3 is 653. If we look under IFC 4, alphabetical listings, and entities, you'll see that there are 776. That means if your Revit model is aligned to IFC 4, but you actually export to IFC 2x3, there is a likelihood that you've exported something that will not work in IFC 2x3 because either that entity or that type or that enumeration is not used. Align your Revit file to the version of IFC that you're using. Let's have a look how to control those subcategories. If we go onto a 3D view for our Kobe assets, have a look at this in the corner. This light fitting. If we go to Edit Type, we can create two properties inside of Revit. One, IFC export as, and one, IFC export type. Some families that you download from the internet will have these preset. It's also worth pointing out that later versions of Revit, such as Revit 2023, control this workflow differently. However, in this version of Revit 2022, we have to do it manually. Those parameters are used with a simple manage, project parameters, and then adding a parameter for IFC export as a type parameter, which is which is a project parameter, and which is pushed out to the given components. Once you've done that, you do the same thing for IFC export type. Within these parameters now, we can type in the type that we want to use against the version of IFC that we're using. IFC 4, IFC light fixture type. IFC 2, light fixture type. This will work in both versions of IFC, so we're happy to use it. Don't forget to check the property sets to make sure that your components in Revit contain all of those property sets, and check any enumerations to see if there's any specific subcategories that you may want to use. Once you've aligned all of your components correctly, we're ready to export. In order to export, we say File, Export, and choose IFC. In the following dialog box, we define a file name for the export, as well as a setup that we want to use. These are known as MVD, Model View Definitions, and each Model View definition is there to either produce an IFC in a different version, or produce an IFC for a very different usage. For example, if I use IFC 2x3 Coordination View 2, it's designed for a coordination view between designers using different software. For example, an architect using Revit and a structural engineer using something else. Therefore, it focuses on quality of geometry, positioning of geometry, and a good level of information. It won't necessarily contain things like COBie data. However, if I use something like IFC 2x3 COBie 2.4 design deliverable, it will focus on both a good quality model in 3D with the piece sets assigned to the geometry to give a good level of property information, alongside a COBie export, so that that IFC file can be used for both COBie production, COBie import, and model workflows as well. We also have several exports for IFC 4. To create a simple 2x3 COBie 2.4 design deliverable export, we choose that setting, we give the file a name, and we choose export. IFC exports can take some time, dependent on the model itself. Once the export's done, we will no longer see progress in the bottom left-hand side. Should we need to export a custom IFC for any reason, we once again go to the export options, but this time choose Modify Setup. For example, we want to use a specific view to export. This might be useful if you've got some particularly detailed geometry that you don't need in your IFC export. So you might just want to use the view that we're in order to export just the visible geometry. To do this correctly, you want to go and create your own setup. That setup can be controlled using a model view definition. And then we get a whole different range of options that we won't talk through in detail today to control how that model will go out. For example, under additional content, we can say only export elements that are visible in the current view. We can control which property sets are used, even creating custom property sets using schedules. For example, if I say export schedules as property sets, but only export schedules with the words IFC, pset, or common in the title, it means that we can create a custom schedule inside of Revit with one of those words in the title, and a property set would be assigned to components with those properties inside them. It's a very useful process. Unless you're told to, within your BEP, try and avoid things like exporting base quantities, because it dramatically expands the amount of time it's taken to export the IFC. Also, don't think that you always need to export every Revit property set, because that will literally export every property against every component in the file, taking a long time and making a very large IFC. Typically speaking, it's better to control what's exported and only export the things that are being asked within the BIM documentation, such as the BIM execution plan. We have other options should you need to use them. One particular one that is of use is the ability to store the global unique identifier against each individual object when you export the IFC. This entire toolset is very well documented online. Following that process, you can correctly export an IFC using Autodesk Revit.